Hello and welcome. This time we'll talk about the last project I worked on in the December. This one was a project on Java for my university. I had a lot of experience with Java in the past, but some time ago moved to Godot, which is less appealing syntactically to me, but more functional and efficient than libgdx. The task was to create a complex application on any theme using Java. And the crucial point is that I was sure that I don't want to do a GUI using standard library. But none of my ideas looked solid enough without a user interface, so I decided to make a game to use the features of the game engine. The final plan about this project was to create a full-stack online Pong game with client-server interactions, lobbies, and etc. And I want to mention that creation of this project was a team effort. So shoutouts to my companion. She put a lot of time and effort into this project and wrote whole game engine part and some of network stuff on her own. Great job! I was mostly working in this project on fundamentals of networking and also on client side, where I have set one more challenge: to use only primitive geometry and 4 colors, while at the same time make it look cool, which I think I succeeded, using a lot of cool effects, one of which is palette swap that lets player choose color scheme for a game screen from 12 possible variants. Shoutouts to all the authors of these palettes and site lowspec.com, where I found them. This graphic is very simple but still quite decent, and I'm proud of it. But the actual magic happens under the hood of it, in the code, where the whole network interaction happens. And the important point here is that libgdx net library only adds a bit optimized versions of low-level network classes, which is important for mobile frontend, but it lacks some features of Java standard library, which are important for server-side, specifically asynchronous I/O. So this library has strong and weak sides, but in the end it's still only a low-level net library. You won't find any high-level features here, and you'd have to create your own communication protocol, and be faced with a lot of difficulties like fitting all the packages into the buffer, request deprecation, in other words figuring out what to do with received data, sanitization and protecting of your system. Let's talk about these problems, assuming that we want to create a chatting app. So, data that we want to send is just a text. We turn it into bytes and restore on the other side. That's it. But we don't even know who the sender in this example is. We can either add the name to every packet that we are sending, or add a new command to our protocol. Expectedly, the second approach is more scalable, so we will go with it. But we need to send 2 parameters through the network in both cases. How can we do that? Well, we can define some sort of delimiter character and split data and get a whole bunch of problems in the long run. But it's better to just use machine-readable text format like XML or JSON. Personally, I prefer JSON. This is what we are sending now, to set nickname and to post a message. We've solved the request typization problem, and we can easily solve buffer size problem. If the packet is too big to get in the buffer, the whole packet is still there, it's just waiting in the stream to be processed. So we just need to obtain data from it until the point when we have a complete packet, which we can understand by checking that it's a valid JSON object. Now, if we start scaling our system and add more command types, we'll get a huge if statement. To solve it, we can use pattern called command, which turns this if into a loop. We can also change our typization from strings to enums, which will make it more stable, because now we are storing a list of all possible types of commands in one place. But there is still a huge issue with this protocol. Obviously, we'll get to the point where we need to send more than 2 parameters at the same time, so we need to use a map to store them. And furthermore, we need to store values of different types in this map. That said, now we are relying on promises, that there will be a map field with values corresponding to the enum, and that these values will be of corresponding types. So we need to make sure that these promises aren't broken every time we receive data. And this is a okay situation. The actual problem is that we are creating promises on the receiving side, but expecting sender to fulfill them, while not giving them information about our expectations. Solution to this problem in our project is one I am the most proud of. The idea behind it is simple: to change a point from which the command is sent. In the shown example, we are sending data through the network, extracting it from JSON, and then decide which command to send. But what if we try to send command from the client itself, skipping all the steps? Obviously, we won't send code through the network for security reasons, but what we can send is a JSON representation of some object. In this way, sender first creates an object passing data into it, which grants that all the promises will be kept, and sender knows what data they need to provide. Even if promise is broken for some reason, it will be known in the process of deserialization and casting the data to a specific type. But wait, you can't just serialize an object and expect that this JSON will be deserialized to the same class without knowing specifically which class it is. Well, yes and no. Yes, you can't just send an object and restore it without knowing its class. But I'm not sending some object. I'm sending a parcel which is container for any other object, specifically a command, and it stores a class of this command in a separate field. This, in conjunction with a custom deserializer, leads to an ability to create command on the client and execute it on the server as easy as calling a few functions. And this is how I created the fundamental part of this project, networking protocol. Everything else was built upon it, and there wasn't any serious faults in this system. The story of our multiplayer Pong clone ends here. But, as I said, there isn't a lot of tools for libgdx that helps you with client-server interactions. So I'm planning to turn the core of this game into a standalone open source project which will help libgdx game devs to create multiplayer games easier. This game is also open source. You can find source code of this project on GitHub. You can find links to this and other socials where I post short updates in the description. Consider subscribing and ring the bell to stay tuned about the projects I'm working on. But, for now, thanks for watching, leave your comments below, I'm answering and appreciate all of them. I'd also love to hear if you have any ideas for the future logs and other activities. Thanks for watching, stay safe, have a good day, and bye!